Okay, now let's continue our discussion of permutations and cycles. And before we get started, I do want to bring to your attention an unfortunate coincidence in notation for a cycle. It just happens to coincide with a notation for a point in space. So just be aware of that. When you see it, it's not a point in space, it's a cycle. Sorry about that coincidence. But let's get started here. A cycle is a permutation that can be written in the form, that looks just like a point in space. And by the way, when we talk about those entries in that cycle, they have subscripts, and the way we commonly refer to them is by using the term sub. So if I want to talk about the second entry in that cycle, the one with the A and the subscript 2, I will say A sub 2. That's a common way of referring to those sorts of things if you didn't already know that. But continuing, this means that each entry is moved to the next entry's position. So A sub 1 to the A sub 2th position, A sub 2 to the A sub 3th position, and so forth until the last entry, A sub S, is moved full circle to the position of the first entry, A sub 1. And this will become, I think, more clear as we proceed. For example, the cycle 1, 3, 2 moves 1 to the third position, 3 to the second position, and 2 to the first position. Although 4 does not appear in this cycle, we may regard 1, 3, 2 to be a permutation on the set 1 through 4. In this case, 4 is moved to the fourth position by default. That is, 4 stays in the fourth position. In fact, the cycle 1, 3, 2 is actually the permutation 2, 3, 1, 4. We will now verify this fact. And actually, before we verify that fact, let's just clarify a little bit. We can think of the cycle 1, 3, 2 as a permutation on the set 1 through 3. Or we can think of it as a permutation on the set 1 through 4, or 1 through 5. We just have to specify, actually, if we're talking about what set we're talking about, really. Anyhow, let's verify that fact, like I said. Okay, so now we have our cycle 1, 3, 2, and below it we have 4 positions that are in question, as denoted by the question marks. So starting at the left of the cycle, we start at the first entry, 1. And the question is, well, what position does 1 take in the permutation? Well, you look directly to the right of the 1 and you see a 3. Okay, so that indicates that 3 should be in the third position. And so, 1 should be in the third position. And so we write 1 in the third position. Okay, and moving 1 over to the right, we now turn our attention to 3 and ask what position in the permutation would 3 assume? Well, look to the right and there's a 2. So then 3 should be in the second position. So that's how we write it. Now moving on to the 2, in the far right of the cycle, we ask, well, what position should 2 take? Since we're at the end of the cycle there, we go around to the beginning of it, and we see that there is a 1. So that means that 2 should assume the first position in the permutation. So we write it that way. So now, if we're talking about permutations on the set 1 through 4, then what position should 4 take? Well, the fourth place. So we write it that way. And thus the permutation would be 2, 3, 1, 4. Okay, moving on. Success. Moving on. Okay, so it should be noted that the representation of the permutation 2, 3, 1, 4 is not unique. Okay, that is, the representation in cycles is not unique. The viewer should verify that both 1, 3, 2, which is the cycle we were dealing with, and the cycle 3, 2, 1 represent the same permutation. So if you were to do the same procedure on the cycle 3, 2, 1, you would find that it is the same ordering of the numbers 1 through 4. Okay, so that is, both cycles represent the permutation 2, 3, 1, 4. And moving on. It should also be noted that although every cycle is a permutation, not every permutation is a cycle, strictly speaking. Okay. For example, the permutation 3, 1, 2, 5, 4 may be visualized as follows, as I've, a little diagram I've made there. And let's actually first turn our attention back to the permutation 3, 1, 2, 5, 4. Notice that 3 is in the first position. Okay. 1 is in the second position. 2 is in the third position. Okay. That's represented by the leftmost part of the diagram. And if you look at that, and if we're going clockwise, where does 1 go? Going clockwise, 1 goes to 2. So that means 1 should appear in the second position. And if you look at the permutation, that's exactly where it is. It's in the second place. Now going clockwise, we go to 2. Where does 2 go? 2 goes to 3. So 2 should appear in the third position of the permutation. And if you look at the permutation, 2 is in the third position. And 3, continuing to go clockwise, should go to 1, or the first position. And looking at the permutation, 3 does appear first. But what's left out of the loop here are 5 and 4. 5 is in the fourth position, and 4 is in the fifth position. So those two are connected in that way. 5, it goes to 4, and 4 goes to 5. So this permutation can't be represented as a single cycle. It can, however, be represented by multiple cycles, as will be discussed. In fact, the diagram that I've made here, these two figures represent 2 cycles, both of which actually make up the permutation 3, 1, 2, 5, 4. But it's not a single cycle. So that's why I say that a cycle is a permutation, but not strictly speaking the other way around. But we'll have more on that later in a later episode.